Hi, this is Bob Weisickle from OakGate Technology, and we're here at PliantTechnology's System Validation Lab, and we're here to do a demonstration of Pliant's latest release called the Enterprise Flash Drive. Here's an example of the drive that we're going to be doing some performance benchmarks around. As the President and CEO of OakGate Technology, OakGate has been engaged to really be the tool set by which this performance can be validated and tested. OakGate is a Granite Bay, Roseville-based company, and our focus is really in providing world-class performance, characterization, and system validation tools. So what we have is this drive in a ZT Systems JBOD. There are 16 drives connected to a pair of OakGate Technology servers. At this point, let's move over to the controller, where we will actually configure the test and run the benchmark. So what we have here is the OakGate Technology System Validation Framework and Performance Characterization software. We're in the process of configuring a benchmark. Thought the first one we would do is really one that is very real-world type of workload. So what we're going to do is configure this to be 100% random IOs. We're going to configure the test to be 4K reads and 4K writes. The next thing we're going to do is create a balanced workload of 80% reads, 20% writes, and we'll set a queue depth of 64 for each of the drives. So what we're going to do is have 16 drives with this 4K read-write workload, and I think a reasonable queue depth of 64. So what I'm going to do is configure all the drives to get the same workload, and then we're going to start this test, and we'll look at what the performance numbers are. So what you can see is we're doing almost 1.1 million IOPS, 4K IOPS, and over 4 gigabytes of throughput out of these 16 drives and these 2 servers that OakGate's driving. So this is a phenomenal number in terms of throughput and performance for a real-world type of workload. What's also phenomenal about the number, besides this number itself, is the stability of the number. The number continues to be very stable, the fluctuation is very small, and the performance is really what you would expect from a real-world type of application and use of this particular technology. So I guess in closing on this benchmark, I think the numbers are phenomenal. The product stability and consistency of these numbers is outstanding and represents, I think, a world-class achievement in terms of performance. This time what we're going to do is focus on really a more synthetic benchmark. It's using the 512-byte block size and a 100% read. And this is really trying to see what the maximum I/O rate of the drive is. Again, it's 100% random. We're going to set the block size down to 512 bytes. We're going to do a 100% read workload. So I'm going to move this indicator here to 100% reads. We'll leave the queue depth as we've always had it at 64. We'll configure the 16 drives as we did before, and we will start this test. So if we look at the results of the test running, you can see at this point with 512-byte IOs, we're at about 2.4, just shy of 2.4 million IOPS, and over 1 gigabyte of throughput. What's phenomenal is, besides this rate of performance, again out of 16 drives to get almost 2.4 million IOPS, is also the sustainability and consistency of these numbers, and these numbers are absolutely stable and repeatable. So the combination of this level of performance and this type of predictable performance, I think, will be a very positive in terms of being able to give customers something that they can realize in their own applications. So our next benchmark that we're going to run on the Pliant drive using OakGate Technology's test environment is really to see what the maximum bandwidth is that we can get out of these 16 disk drives. So what we've done is configured the test to be 100% random. We're going to do 64K block size IOs, and we're going to use a 50% read-write ratio. So we're going to do half reads, half writes. Set the queue depth up still for 64 per drive. We'll go ahead and configure this for all of the drives, and we'll start the test. What we see is on this 50% workload, we're doing in aggregate almost 9 gigabytes of throughput, about 8.6 gigabytes of sustainable read-write workload for streaming video and other streaming types of sequential workloads. Even though this is set up as a random read-write test as kind of a worst case, the performance is just absolutely phenomenal. So if you like what you've seen today and you'd like to follow up and get more information, feel free to contact Pliant Technology at www.PliantTechnology.com or connect with me at OakGate Technology at www.oakgatetechnology.com.